Welcome back, folks. Let's work on this next 10 elements. Okay, next element would be sodium. 11 electrons. Okay, so for the 11th electron, you should be on the 3s orbital. Okay, so the full electronic configuration for sodium: 1s2, 2s2, 2p6, 3s1. Next element, magnesium, 12 electrons. Okay, this 12th electron should be on the 3s orbital because it has one more empty spot. But of course, the 12th electron should have the opposite spin quantum number, -12. All right, the electronic configuration: 1s2, 2s2, 2p6, and 3s2. Next element, aluminum, and in this case, the 13th electron should be on the 3p orbital. Okay, so for aluminum, would be 1s2, 2s2, 2p6, 3s2, 3p1. Okay, next one, silicon, 14 electron, and of course this 14th electron should be on the 3p orbital. 1s2, 2s2, 2p6, 3s2, and 3p2. Next element, phosphorus. Okay, 15 electrons. So the 15th electron should be on the third 3p orbital. 1s2, 2s2, 2p6, 3s2, 3p3. Okay. The next element, sulfur. Okay. Sulfur, 16th electron, and so this 16th electron should be on this first 3p orbital. So for sulfur, 1s2, 2s2, 2p6, 3s2, 3p4. Okay. Next element, chlorine, 17th electrons should go to the second 3p orbital. Okay, so it will be 1s2, 2s2, 2p6, 3s2, 3p5. Okay. Now the next one is going to be argon, 18 electrons. So of course the 18th electron should be on the last 3p orbital. So for argon, 1s2, 2s2, 2p6, 3s2, and 3p6. Okay. Now this is the 18th element, argon. The next element, potassium, 19 electrons. So in this case, the 19th electron should be on the 4s orbital. Okay, so 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. All right, the 20th element, calcium. So the 20th electron should be on the 4s orbital. For calcium, 1s2, 2s2, 2p6, 3s2, 3p6, and 4s2. Okay, so these are the full electron configuration for the for these 10 elements. Now let's figure out the noble gas core electronic configuration for each one of them. Okay, for sodium, okay, which noble gas core we should use? You have two options. You can use helium, or you can use neon. Okay, you can use neon. Well, again, because scientists realized that these 10 electrons are the core electrons. In other words, those 10 electrons will never be part of the chemical reactions of the sodium. Okay, so and this the only electron that will be part of the will be involved in the chemical reaction with sodium is just this 3s1 electron. Okay, so we will use the neon as the noble gas core for sodium. Okay, so for this one, let me use a red color. So it would be neon 3s1. Okay, we use neon with a bracket to represent the 10 electrons on the 1s, 2s, and 2p orbitals. Okay, same thing for magnesium. Okay, we use neon to represent the no core electrons. Neon 3s2. Okay, for aluminum, neon 3s2 and 3p1. Okay, now for silicon would be neon 3s2, 3p2, and phosphorus neon 3s2, 3p3. For sulfur, neon 3s2, 3p4. For chlorine, neon 3s2, 3p5. For argon, neon 3s2, 3p6. Okay, so these are the elements with the neon core. Now the next element, potassium. Okay, well, for potassium, it's going to be different from these elements. Okay, because if you take a look at the full electronic configuration of potassium, these electrons, these 18 electrons, will be the core electrons. In other words, those 18 electrons will never be part of the chemical reaction of the potassium. Okay, and those 18 electrons happen to have the same configuration as argon, right? As argon. So we use argon to represent the core electrons of potassium. So for potassium, it's going to be argon core electrons. And then for S1, valence electrons. For calcium, again, you can see the argon core, 18 electrons here. So the core noble gas core electronic configuration for calcium would be argon for S2. Okay. These are the so right now we know the full electronic configuration and the noble gas core configuration of the first 20 elements. I want you to be very familiar with this both configurations for the first 20 elements, okay, because they are required. In other words, these elements, first 20 elements highlighted by the red square, they are required. Okay, if I ask you to write either the full electronic configuration or the noble gas core electronic configuration of one of the first 20 elements, I need you to know how to do it. Okay, that's my expectation. Now let's take a look at this periodic table. This periodic table shows you all of the elements, okay, organized by their the group numbers. Okay, for instance, this lithium, sodium, potassium, they are in the same group. Okay, boron, aluminum, gallium, they are in the same group. Okay, again, the reason why we organize them is because they have the same chemical property. And more importantly, if you compare the electronic configuration, the valence electrons, you will see that they have similar valence electrons. Okay, for instance, the first group here, lithium, sodium, potassium, they have 1 electrons on the s orbital. For the group 2, they have 2 electrons on the s orbital. Okay, and the group 3a, you have 2 electrons on the s orbital and 1 electron on the p orbital. Okay, it's because they have a similar valence electronic configuration. We put them in the same group. They share the same similar chemical property. That's the reason. Another thing I want to mention here for this periodic table is the different blocks. Well, the blue block is called s block because you have electrons, valence electrons on the s orbital. P block, the purple one, you have valence electrons on the p orbitals. Of course, also the s electron. D block, the yellow one, you have valence electrons on the d orbital. F block, you have valence electrons on the f orbital. Okay. All right. Now let's do some very quick practice. Determine the element for each electronic configuration. This noble gas core electronic configuration. Well, from previous slides, we wrote the full and noble gas core electronic configuration for the first 20 elements. Okay, so you have each element, the chemical symbol, you identify the electronic configuration. This problem is asking you to do the opposite. Gives you electronic configuration, asks you identify what the elements are. All right, it's actually quite simple. Okay, when you look at this electronic configuration, it's argon 4s2, 3d10, and 4p6. Well, at first look, it would be a little bit confusing, but if you know that the position of those elements or the identity of those elements is defined by the number of the protons, then it would be easier. Because remember, these are the neutral elements. Okay, the problem doesn't see anything neutral, but if it is neutral, it will tell you. Okay, if it doesn't see neutral, you always assume it's neutral. Okay, so elements are defined by the number of protons. Okay, because they are neutral, so the number of electrons equals to the number of the protons. In other words, if you can count how many electrons you have for this element, you should be able to identify how many protons you have, and you should be able to identify what the elements are for those two configurations. Let's start from this one. We know that argon, right here, you have 18 electrons. Okay, so let me write it here. 18 electrons for problem A. 18 electrons from argon core, right? And then the 2 electrons on the 4s orbital. So you have 2 electrons from the 4s orbital, and 10 electrons from the 3d orbital, and the 6 electrons from 4p orbital. Okay, so if you do the calculation, add them together, you have 36 electrons. Okay, as I mentioned, that because this is a neutral element, 36 electrons, it tells me that this element should have 36 protons. In other words, the element should have this many protons. Okay, so from the periodic table, you see that krypton is the right element for this configuration. Okay, so let me write it here. So it tells us the answer is krypton. Okay, so it's just a simple addition. If you know how to do it, it would be quite straightforward. Now the next problem, question B, still argon core. Okay, and then you have 18 electrons, of course, from argon core. Now you have 2 electrons from 4s orbital and 2 electrons from 3d orbital. So total, you have 22 electrons. Neutral element, 22 electrons, tells us it should have 22 protons. So if you go to periodic table, you'll realize, well, this element actually would be titanium. All right. I hope this video shows you how you identify the full and noble gas core configuration, electronic configurations for at least the first 20 elements. And if you have any questions, let me know.